in today's video, we're going to be looking at volume again. And in the last few videos, we've talked about volume equals length times width times height. We're going to introduce another formula today, and that is volume equals base with a capital B times height. And in this case, the capital B means the area of the base. The area of the base. Now, in your minds, can you think about what is the formula for area? Now, this is a lot to keep straight. So area equals length times width. So if you notice, area is already a part of the formula for volume. We just don't always refer to it that way. So this big B is just another way of representing length times width, the area of the base. So I'm going to get rid of all of those, and let's look at these two separate problems. There we go. So for this one, we have the length, the width, and the height. So volume equals length times width times height. And our length from left to right, I'm going to keep saying that, length left to right, 7 centimeters. The width from the front to the back is 5 centimeters. And the height from the bottom to the top is 4 centimeters. So if we multiply all that together, again, I like to do it in the way that's easier for me to multiply. So I'm going to start with 5 times 4. 5 times 4 is 20. And then I'm going to bring down the 7 times. So 7 times 20, 7 times 2 is 14. Then with another 0 at the end, it's like multiplying that by 10. So 140. 7 times 20 is 140. We're dealing with centimeters this time, so that's centimeters cubed. Remember that exponent shows us that it's 3 dimensions. Okay, now let's look over at this other problem. So we've got volume equals, and remember this time it is big B for area of the base times the height. And as you can see here, the area of the base, the length times the width, is 36. Oops. The length times the width is 36. Then our height from the bottom of the prism to the top is 6 inches. So we're left with 36 times 6. I'm going to work that out off to the side here. 36 times 6, 21. So 36 times 6 is 216. And in this case, we're dealing with inches. So 216 inches cubed. So as you can see, we have our exponent of 2 here, and then we have 1 more inch. So that's where we get our 3 dimensions of inches from. Okay, now moving on to our practice. Our practice is going back to deal with area. So let me draw out a problem for us here quickly. Ooh, that wasn't the greatest. That will work though. So if we go for our area, remember, well, we can do area a number of different ways. One of the ways to think about is area is length times width, which we just talked about with volume. So our length left to right, 1, 2, 3, 4, 5. And our width is 1, 2, 3. And we're going to call this section up here, we're going to call that section 1/3. So 3 1/3. As I'm going through this, remember there's a number of ways to do it. One of the ways is by counting squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then that's going to be hard to write in there, but this is 1/3, 1/3, 1/3, 1/3, and 1/3. Sorry, that's so hard to see. So our answer, there are 15 total squares, and 1, 2, 3, 4, 5 of our thirds, 15 5/3. We could take these 5/3 and think about it as 3/3 plus 2/3. This 1/3 is the same as 1, so we could make that 1, which would give us 16, and we'd be left with 2/3. So 16 2/3. Or if we thought about it as area equals length times width, it's a little bit different with our fraction here. But to think about this, we would do it in two different ways, and hopefully this is clear when I write it. So we could go 5 times 3, which is 15. Then we have to take our 5. Then we have to take our 5 and multiply that by our 1/3. And there's 5 1/3 pieces, which is going to give us 5/3, which gets us to this point here, and then we can turn it into a mixed number. Now, hopefully that wasn't too confusing, all that I went through, but at least it'll give you a reminder of how to do problems like that. So whether you count the squares or you multiply it out, either way works. Choose whichever one is easiest for you. And thanks for watching.